So this is integrating elastic data analysis with OpenStack Sahara. I'm Ethan Gafford. I'm a software engineer at Red Hat. I work both upstream on the OpenStack Sahara code base and downstream doing productization and packaging and all that within our RHEL OSP OpenStack platform. This is just sort of where we're going. We're going to talk about what problem we're defining, then talk about Sahara. I was asked, what is Sahara and what are we all doing here? We will address that directly. And then the real meat of this presentation is going to be talking about what bits of Sahara to use to most successfully get the results you want within a number of different use cases. How to use it for dev test, how to use it for research, BI, production. I'm doing something maybe a little bit bold here, where Sahara is really, in a production mode, it's only been really around for about 6 months, right? It went GA or general availability in OSP only about 6 months ago. The whole project is really pretty new, but still I'm going to spend most of the session talking about, instead of what is it, how would you use it, and what bits you would want to use if you actually went ahead and implemented it. So this is less of a sales thing and more getting into what parts you'd want. Then we're going to talk about future features, sort of what's coming next in Sahara, and how they might be able to help you do even more things with it. Because it's a pretty small room, I think I'm going to hope that we can sort of stop for questions after each section, rather than just at the end. It seems completely unnecessary to only have one section of questions. Beyond that, a caveat, I did have some demos prepared. They are more or less not going to be possible. The Wi-Fi is not permitting me to hit my servers. I spent most of this morning trying to spin up an OpenStack VM so I could do it locally and at least show you what we would do, and couldn't get a long enough period of uninterrupted internet connection to spin up that VM. So here we are. Happily, the presentation is not very demo dependent at all. So what we're talking about today is, we're talking about big data processing engines. And the promise of big data processing engines, they really are telling us that they're going to do 4 things for us. They're going to give us huge amount of power so that we can scale to hit any amount of data we want to. They're going to make us able to write algorithms that are going to be able to deal with heavily distributed workloads without knowing a ton about distributed data processing, consensus algorithms, all these bits that are actually really difficult. It's going to get rid of for us and just let us concentrate on our code. It's reliable. It's built to expect failure. We can run it on community hardware. Makes it cheaper to run. Great. And it's elastic. It can scale with your workload easily. And we are, of course, talking about a bunch of different big data platforms here. It's been sort of the Hadoop show for a while. Spark's coming up. Storm's coming up. It's very much not just the Hadoop show anymore that we're talking about. And 3 of these promises, most installations of big data platforms do really well, right? Power, power, abstraction, and what was I talking about? And reliability are pretty well built into the platforms, and they work, and we use them, and they're great. Elasticity in a lot of production environments is a lot harder to run into. And I know, I was a Hadoop developer at an ad tech firm for a while. We were just adopting, Hadoop, just adopting MapReduce, and we got to this point where, we had a fixed size cluster. It was great, and then people kept using it, which is exactly what you want. But we had no way operationally to really scale that out quickly. Development was kind of a nightmare because a lot of bugs only occur at scale. And so this is the problem that we're dealing with. The reality is that operationally, if you have a sort of pet cluster of Hadoop VMs, or Hadoop nodes rather, where those are your Hadoop environment, you can't throw them away at will. Do we all know the pet cattle distinction? We're familiar? Cool, go on. So not being able to sort of, throw away your environment, rebuild to a fresh state quickly costs a lot of money. Development and testing concerns, a lot of bugs only occur at scale, so you really have to have at least a realistic-ish environment to really test your code before you go live. Using up real cluster time on a real shared, potentially production cluster is really expensive. Organizational demand, if you have a fixed size cluster, if you're in that early stage of Hadoop adoption, that can be great for a while. You will inevitably need to scale though. But devoting all of those resources to just your Hadoop cluster all the time can be really nasty. And of course, the other elephant in the room here is that there are services that provide this. There is AWS, has Elastic MapReduce. There are a number of platforms. The problem is that there, you're vendor locking yourself to a very specific tool set and a very specific corporation, which may, its policies may fit you now, or you may still be paying more than you'd like to. Regardless, though, those policies could change. And you're very much tying yourself to a much larger entity than maybe you'd like to. So they're harder to provision and scale than we would like. That last elasticity promise is not quite there in a lot of production cases. And that can be very painful. And that's what fundamentally we're here to talk about and address. So if you are not if you're not interested in using big data at all, if you have, if all of your developers are perfectly happy with their current development environments, if your production and research clusters are perfectly scaled, there's never waste, there's never contention, you're living in Shangri-La, everything is beautiful. You can go now, and I would like to talk with you after this presentation about how it can be you. But in the meantime, we're going to talk about OpenStack Sahara. So Sahara, of course, is an OpenStack component, which is essentially a provisioning, a big data cluster provisioning and elastic MapReduce layer within OpenStack. OpenStack, I hope we know, is a rising cloud platform, all open source, being contributed to by a large number of corporate and non-corporate contributors, very much including Red Hat. Sahara gives you sort of easy and standardized interfaces to create clusters, to scale clusters, to run data processing jobs. And it does this sort of with as much one interface as it can across versions of Hadoop, across HTTP, Hortonworks data platform, CDH, Cloudera, Spark, Storm. So it's got the pure vanilla upstream products, the vendor-specific products that have emerged for support, and as well as some of the newer pure open source solutions that are emerging in the market now. And it's designed so that the default cluster that you spin up is just going to work pretty well for most use cases. It does have very sophisticated configuration management for expert users. You can configure just about whatever Hadoop cluster you'd like to. And that's fundamentally what Sahara is and is trying to do. This is sort of what Sahara is architecturally. You can see this whole box that is the OpenStack control plane. We sit down there. Everything in red is Sahara. So we have an API which you can use directly as REST over a command line interface or via the OpenStack dashboard Horizon, which I was hoping to show you and won't, which is lame. But it then talks down to the OpenStack Sahara engine, which goes through these vendor plugins. And they may actually be vendors like Hortonworks or Cloudera, or they may just be open source projects. Vendor is a little bit inappropriate there in a lot of cases. But yes, please.
You're talking about scaling.
Mm-hmm.
That, and there are a lot of talks in the past few days about Kubernetes.
Yes.
Its ability to do pretty much that.
Yep.
Can you explain how those two relate and whether they are overlapping or whether
Sure. So we'll talk about containers a little bit later, but we can address this a little bit now too. So there are sort of three different ways of provisioning nodes or processes, or provisioning things that the user wants within OpenStack that are emerging. Traditionally OpenStack's been very VM centric. It's all about virtualization, and you spin up n nodes with these resources, and that's what you do. More recently, there's a project called Magnum, which is very much addressing the containers in OpenStack space. There's also a project called Ironic, which is all about bare metal provisioning within OpenStack, just taking over an entire physical server. The Sahara team is going the second way, a little bit more than the first way, just because containers are really, really amazing, especially at allowing you to very quickly deploy n of a thin, stateless process, right? Like web applications, they're fundamentally amazing at that. We're not as convinced that in the big data processing space, where a lot of the time you want coupling to your data set and you want massive nodes, that makes as much sense, right? So does that answer the question? Cool. And we'll stop for questions after this section as well. So the Sahara engine uses a ton of different OpenStack services to deploy your nodes. Our compute service is Nova, block storage, image, and the orchestration service to tie it all together. And that basically goes out and deploys the actual VMs of your cluster, or if you're going to use Ironic in the near future, the physical servers of your cluster. Those vendor plugins then take over and run any configuration necessary to sort of tie the cluster together to itself, to configure the DNS sometimes, and if you're running CDH or HTTP to sort of start those manager processes, pull the nodes in, get everybody talking to each other in a good active state where you can run jobs. So the API is here. You can see the cluster management API is up there in blue and the EDP in red. Cluster management, you register a sort of base image that's going to contain your data processing framework. You then create node group templates, create a cluster template, and launch the cluster. We'll go into this in a little bit more detail later. After that, on the EDP side, you can do something called registering a data source, which we'll also talk about in pretty decent detail later. Register your job binaries and have those as standardized reusable objects. Create a job that you can run repeatably. And then finally, run a job against a cluster. And that's sort of what we do here. Are there any questions at this point? OK. How are we doing for time? We're doing just fine. Cool. All right. So as we've talked about in the past, what we are going to talk about today is which features to use for which use case. We're going to focus and we're going to talk about the feature set rather than going over the specific API calls. We're developers. We know how to read a REST API. One thinks, and then learn what is coming up next in Sahara as well. So in this next section, we're going to talk about using Sahara as a dev test environment. I remember that when I was a Hadoop developer, basically I would run very, very small jobs locally until I thought they were good enough, and then I would push them to a resource within effectively our production cluster. I think this is probably what a lot of people do at this point. There's one cluster when you're starting out, and that's what it is. The problem being that as teams get more interested in Hadoop, you end up rapidly exceeding the capacity of your fixed size cluster. Additionally, if you're a developer or tester and the production cluster, that one shared cluster, heaven forfend, is broken, your entire effort stalls. And that can involve other teams. You can have to pull in operations. You can have to pull in all sorts of people that you don't want to deal with because you just want the thing to work by deadline. So this is actually an extremely simple case to run with OpenStack Sahara, because most of the time in this case you're not really worried about perf overwhelmingly. You want to see that it works. But seeing that it runs blazing fast the first time is not necessarily the most critical thing in the whole world. And you're going to get a pretty good picture, even through n layers of virtualization, of how well it's going to do in the end. So as we've talked about, first step is to define your node group templates. And what these are, a node group is basically, if I'm in Spark, that's going to be my Spark master versus my Spark slave. In Hadoop, that's going to be my name node, my secondary name node, and my worker, right? You pick which processes you want to run on each of those types of nodes. And you can provide any process configurations that you want to. Any that you select, you're going to get, if you're using the UI, you'll get an interface for a long, long list of configurations that you can set, or you can just go directly through the API. You can define security groups with accessible ports. We do have an auto security group feature that spins up sort of the right ports for the processes that you've got. And if you've got a dev OpenStack installation, defaults by generally going to let anything through. So defining cluster templates at that point pretty much is just a map of node group type to count in most cases. There are some advanced features where you can override specific node group configurations. You can also do something called anti-affinity, where if you don't want more than one worker node running on a specific actual physical server, you can declare that. And the compute engine will attempt to schedule appropriately, which will often be very useful. And then you go ahead and create your cluster. So at that point, you have a Spark cluster, you have a Hadoop cluster, et cetera. You have some options as to how to use it. You can use it through the Sahara EDP API, which basically sort of abstracts away a lot of different types of MapReduce jobs. You can throw Pig in here, you can throw Hive in, straight up Java jobs, as well as Spark jobs. The nice thing about the Sahara EDP API is that if you do get in the habit of using this, at least on the development side, if you do get in the habit of using this and you do decide to change your engine, the underlying engine, if you go from Hadoop to Spark, at least you'll have some, well, not Hadoop to Spark necessarily, because that's a whole different kettle of wax. But if you move from plain old Hadoop to Cloudera or to Hortonworks, those same jobs the exact same jobs can run on that new vendor. So you can sort of help yourself avoid lock-in that way. Of course, you are committing to OpenStack in that case, but maybe that's okay with you. Or you can just run them as per normal. Once you have your Hadoop cluster, all of the normal interfaces are going to be there. You're going to have Resource Manager. You're going to have your name node UI and CLI and your REST interfaces all available to you. So you can use them precisely as you always have in the past as well. Any questions thus far? OK. So one issue that's sort of obviously going to come up for most people adopting this is that OpenStack is fairly new. Not a ton of people already have it. Actual installation of OpenStack would be a whole nother talk and probably a lab, and would generally take way more time than we have here. But if you are doing this purely as a developer cluster, DevStack is absolutely an option, and you can set this. You can run DevStack on the master branch if you're feeling really lucky, or you can use any of the stable branches that you like to, which I would suggest if you're using it. If you're not actually developing OpenStack. If you have trouble with it, please ping us. We will help. We want it to work. Beyond that, RDO is the community edition of OpenStack on Red Hat Linux, runs on CentOS, on Fedora. It's sort of our packaging of DevStack before our product layer. It's our midstream. And then finally, RHEL OSP is the enterprise version where, if you're subscribed to Red Hat OpenStack, you get this. You can open support tickets and, keep us up nights if things are going too badly for you, which is very useful. Let's see. Any questions on the dev test case before we move on? OK. So next, research. This is a pretty common case in a lot of organizations, especially ones that are new to Hadoop and to MapReduce as a whole. But even past that, very frequently organizations are going to want to do one-off investigations of their own data to find out what they can see about it. Maybe it'll bear fruit. Maybe it'll just be noise. We don't know until we do it. But it's not going to be a recurring job. It doesn't need to be part of our workflow. These resources that we're allocating it don't need to be persistent in any sense, right? So in this case, Sahara really, really shines because basically what you want here is the exact opposite of what these platforms do by definition, right? Hadoop, Spark, Storm, et cetera, are designed to couple their data layer pretty tightly with their compute resources. They do that for performance. There are great reasons why they do it in production cases. But Sahara can help you avoid that so that you can have sort of flexible compute resources that run against the same shared data set, are perfectly dismissible at the end of the run, but give you all of the power that you need. So there are a few options for cluster external storage that you have here. The first is that you can certainly share an external HDFS. If you define a data source on an external HDFS, your job can run through Sahara, reach out to that, and use it from your compute node. Alternatively, there's a service that I was talking about with you, I think, a little while ago, called OpenStack Swift, which is an object storage service, very comparable to S3 for folks who have used it, in terms of its functionality, at least. I actually think it has some technical improvements over it, but that's a different story. If you upload your data to Swift, then you don't even have to hit your production cluster necessarily. Any data that's going to be interesting for your research, you can push into Swift, take all that load off of your production HDFS. Also, if you do use Swift, especially for outputs, it makes those outputs very easy to browse. Let's see. Note on data locality. In this case, obviously we are losing data locality. There's a certain degree to which that's our goal, right? If we want flexible provisioning of compute resources, that's just going to happen. Beyond that, network has sped up really immensely since Google published MapReduce in 2004. A lot faster than disk has in most cases. And especially for research, elasticity is absolutely going to trump data locality every day. I have a lot of colleagues who sort of like to talk about, it's not big data until you get to, 10,000 cores or something like that. And it's like, that's cool. It's great. It's really neat when you can do that. But at a certain point, you don't always have to be a hero. This isn't macho. We have a job to do. And in the research case especially, you just don't need it. Part 3, any questions? Yes, please.
So talking about putting the data into Swift, right? So our piece, our data set is giant log files, right?
Right.
You think there's a pack of log files?
Yep.
Would you put it in as
You know, you certainly can put it in as one giant Swift object if you have enough, you know, big enough ring. I would probably suggest that you break it up, you know, by time, just so that, you know, pulling it down, you know, you're probably gonna be pulling it down at once, and you're not gonna want to, you know, to grab the entire thing every time necessarily.
And then do the compute nodes need to have local storage to operate on it? So are they using
Right.
like almost an archive, and then they're caching it locally to do work?
Essentially, yes. Yep. So yeah, they do need some storage attached, but you know, and it depends on what kind of job you're running as well. You know, if you're running a pig job with like multiple intermediate jobs that are part of it, right? You might need more storage. If you're just pulling down that initial data set and then just sending it out to your reducers, and then just creating one small input, you know, you're obviously going to need a much smaller storage footprint. Does that make sense?
Yeah.
Cool. Any other questions? Okay. The next case that we're going to talk about is BI specifically. So in this case, I'm calling this use case BI. It doesn't have to be BI. Basically, what we're talking about here is any use case in which you're running sort of a recurring job against your production data set that doesn't have to feed back into production in a particularly low SLA context. Right? You need this data. It's useful. It can take time. You know, the input size may vary. You know, you may have spikes in your overall data set. You know, blazing fast SLAs aren't critical. You know, having a standing cluster may be useful in this case, but you know, allowing it to sort of scale dynamically with load may be useful too. So this is sort of the most beautiful bit of Openstack Sahara in a lot of production cases. And this time I have just shown the API itself because that's pretty much what you do. And you know, that could be 10, that could be 100. And you know, if you resize that worker node group to what have you, you will have a new cluster that does that at the end of the day. You can also add different node groups to your cluster with this. You know, if you want to add a secondary name node to a cluster that doesn't have one already, perfectly reasonable to do through this. And this will, you know, work across any of the data processing engines that we support. So this is sort of where we're going to get a little bit in depth on production cluster creation. Volume types, you have a number of different storage options in OpenStack Sahara. One of them is called an ephemeral drive, right, where just the compute engine itself says, okay, I'm going to allocate, you know, some amount of memory to be your drive. This tends to be pretty darn slow. You know, the compute engine itself doesn't really specialize in storage allocation. It's really there for sort of, you know, minimal cases or cases in which really fast storage isn't necessarily needed. Swift storage is also great and allows really, really easy compute nodes as cattle, like we've talked about. But it is also slower than some options that you have. Cinder is our block storage engine in OpenStack. That's really going to give you by far the best performance of any of the options available to you. So you probably want to use that in almost any case in which you're actually building a production cluster with OpenStack Sahara. Beyond that, we do at this point, and we'll get to the versioning in a little while, but the Kilo release of OpenStack was just a few months ago. And ROS 7 is the sort of downstream packaged Red Hat release that follows that, that we're actually in late testing on now. In that version, we do actually support data locality. Through Cinder, you can pass this volume local to instance flag, and the compute node will know, okay, you know, I need to put a compute some CPUs, some memory on the same physical server on which I'm going to put a drive of this size, which can help a lot in production, certainly. Beyond that, Sahara is designed to abstract away a lot for you, but the sort of constant refrain in MapReduce of know your workflow still very much applies within Sahara. It allows deep configurations of your cluster, but especially if you're doing dynamic scaling against your data set, against your input set for a specific job, you really, really want to know precisely how that job performs algorithmically. Exactly which steps of the job on which it's going to expand the most, so that you can write a proper scaling function to actually give you the right amount of resources. And of course, JVM configuration. Sahara actually allows you to do much neater configuration of your cluster to your specific workflow certainly than standalone clusters, where you're usually going to have one. You can say, okay, this specific cluster is going to have this JVM size. Mappers are going to be this big, reducers are going to be this big. The whole thing specifically tailored to that flow. So this is sort of getting into the far other side of, we don't want the easiest thing possible. We want the absolute best thing. But sometimes Sahara can actually, if you're really willing to dig into the configuration, help a lot there. Production jobs themselves, fast SLA jobs are probably going to use similar architecture. They're going to use that volume local to instance flag. They're going to use your Cinder drives. I do still have to give the caveat, though, that virtualization overhead is a real thing, right? You are going to lose, probably about 5 to 10% per virtualization layer, and that's storage, that's compute, that's network. Cinder drives can help. As a note here, if you are running a production cluster, just a bunch of disks configuration of your actual physical drives works a lot better than RAID. We lose a ton of performance against RAID. And because you're running Hadoop, Hadoop replicates for you. That RAID functionality is really much less necessary. Nonetheless, again, along the lines of this is a tool, don't be a hero. A lot of the time for spiky input sets, that easy elasticity can still very much win. In a lot of cases, you don't, saying okay, we got 5 to 10% better perf can be wonderful, and you can take it to your executive and get a good pat on the back. But a lot of the time, elasticity is going to save the organization a lot more time and money. Beyond that, though, we do have some new features coming up that may be able to help a great deal along these lines. So we talked a little bit about OpenStack Ironic, right, earlier. This product is essentially baremetal provisioning within OpenStack, right? It has a very cute new mascot, which is like a bear with a drumstick, and it's adorable. But it's a really great product. I have a guy sitting across the cube from me who works directly on it. And essentially what it does is it just does, it enslaves physical servers and pixie boots them at will, essentially. It sort of allows automatic full-on data locality without virtualization layer. It's sort of exactly what Sahara has always wanted, and it's finally here, and it's very exciting for our team. We talked a little bit earlier about Magnum. As I said, the Sahara team is kind of on the fence about containers with these engines and how useful they're going to be. If you have a specific case or have data about your use of Hadoop and Spark and Storm in containers, and you think it's absolutely wonderful, our team would love to hear about it. We're not closed to the idea, but nor are we convinced right now. So we're probably going this way rather than the other. Integration with Ironic is currently planned for the L or Liberty cycle. which started about 2 months ago. It's going to be done about 4 months from now. And then OSP 8, which is the RHEL OSP version that follows on Liberty, will have this integrated. OSP actually already uses this product. It's pretty new, but it's very integral to our new installer, the RHEL OSP 7 Director. Does bare metal provisioning to essentially create your sort of your undercloud or control cloud that the operators use to deploy customer clouds. Beyond that, we do have a lot of EDP improvements coming up. EDP is already pretty, you can use it. It unifies an interface among a lot of platforms. It's very useful. But some platforms may have fuller features right now. We're doing some catch-up in Liberty. Got scheduled jobs coming, directed acyclic graph workflows, interfaces on job templates so that the person defining the job can tell the operator what they want it to require, provide an easy interface to give it to it, to sort of separate out those two roles a little bit better. Again, EDP does allow a lot of decoupling from vendors, so it's pretty useful, and it's getting better over time. And as a note, where EDP is now in terms of just allowing these jobs to run across all these engines, EDP is, I think, at this point, only about a year old from its inception in development in Sahara. So we're talking about a pretty new product. And then one other thing that we have potentially coming up is support for storage layers that aren't necessarily HDFS. HDFS itself is really an interface. It's, at least it can be an interface. It can sit on top of just about anything else. And what we're investigating most directly right now is called OpenStack Manila, which is essentially Sahara. It's provisioning and administration for shared data, and shared file systems. So once we integrate with Manila, we may be able to run against N backends that Manila supports. This isn't definitely planned for L or OSP 8. We're hoping to make it in. We'll see where we go. And that's sort of where. That's actually about where my presentation ends. I see that we've got about 20 minutes left, which about 10 minutes would have been demos. They're not here. Oh well. Any questions?